Hello developers, let's start developing. Today we're gonna take on the day 15 of the 2024 Advent of Code. Note that we're still missing the day 14 because, to be honest, I was busy yesterday. Anyway, my name is Veko and let's start developing. This time we have to do some analysis of a robot that somehow moves inside let's call it a maze. It's a storage space or something like that, and it's moving boxes around. It cannot move walls around, but it can move boxes. And this is how our input looks like. So of course the first thing we're gonna do is we need to parse it. Because it is kind of complicated, I will create a type for that, and the type will be, I will just call it input, since it is consisting of at least two parts. So first we have the warehouse or the map or something like that. We can just call it warehouse, which is an array of actual cells. I will call it a cell array of array. It's a matrix of cells where each cell can be not that. Each cell can be either a wall, and now we're gonna put in some hard-coded things. It can be a wall, that's a hash, or it can be an empty space, that's a dot, or it can be a crate, that's an uppercase O. I think it's an uppercase O, it's not zero, yep. Or it can be our robot, and that's this symbol. So those are the only four possibilities that are legal in our warehouse. And then we have the directions. Let's go overboard with types, why not? So we will have directions, and those are one of these. It's either going up or down, which is V, or left and right. So those are the directions. And so next we have a directions array. So our input will consist of the warehouse and the directions. So we're gonna read all the lines. While line is lines dot shift, we're gonna assume that we have more than one line in the input. If we don't, we're gonna throw here, but who knows. While the line is not empty, move on to the next one. So this will just run through all of the lines that are not empty. But the non-empty ones should go into the warehouse. And yeah, this is quite okay. We're gonna split all the cells on each item, and we're just gonna put them into the warehouse. Note that we are not doing any checks if our data is valid. So if we have something like a C here or an F, this will fail miserably. Fortunately, I don't think that's the case. So let's do that, and let's just check. No, the warehouse is a map, so we will have to do something like this. Print me the warehouse, and then print me the lines, and run. This is a complicated input, so I'm gonna test from the very start whether the input is actually parsed correctly. That looks like a set of things. Let's see if it has any resemblance to the input. So we have our border, and then we have a wall over here, and then the last line has a single crate. The first line has three crates. Seems like we are okay. and the directions seems like we have only those that we want. This is a continuous stream of directions, so means that we will need to join them up. So far so good. Let's continue. So now this is okay, and we're gonna need to get all the lines that are left and map them as that, and then basically join them together. So we can use flat map like this, and this will actually return a list of directions. Flat map takes multiple arrays of something and basically maps them to a single one. Don't trust me. Let's see if we get what we think that we will get. So we should get something like 700 items, and each of them is one direction. Yeah, I said one direction. So we have our direction, we have our warehouse. So we just return that, and of course our input won't be an array of strings. It will be of type input. Of course, this broke this. Let's turn off part 2, we don't need it for now. And just return -1. So we're honest. Here we can also do that. So if everything goes well, we have a proper beginning to our development. So we're running the code for the first part. So now we're gonna need to go through all of the things and simulate the movement of the robot. So the first thing that I will do is make a copy of the initial warehouse. I don't want to destroy things because we will actually need to move the crates around, and we will move the crates around. So the original input will get broken. So our warehouse is that, and of course we can take a copy of the directions. It doesn't really matter. So now the solution is kind of simple. We're just gonna need to loop through all of the directions and update. Yeah, let's have this be the warehouse. We're gonna just say warehouse is update warehouse, the warehouse with that direction. Yeah, this might be a bit memory inefficient, but we will have a method that says update warehouse. I don't think this is the correct implementation, whatever it is, and we're gonna copy our input and then return our input. So this is a dummy implementation, but the setup seems okay. So at the very end, we will just need to calculate all the crates. Fortunately, we have a much smaller input that we can actually work with. And this kind of makes more sense because in the description of the task, it actually shows us what it will do. And after all the moves, we should get this scenario. No, this scenario basically. And this is the end scenario for the last one. However, we just need to calculate the, what is it called? The sum of all boxes GPS coordinates. GPS stands for Goods Positioning System. So the sum should be around that, and the sum is calculated. So in a certain way, we'll take care of that. So let's have it just return -1 for now. However, what we can do, we can try to replicate this thing. And yeah, we can even do this. So initial state. I like replicating what was given in the task, which means that we're moving in the right direction. So console log initial state, and then print matrix warehouse. Yeah, we have our initial state, we have that, and if we actually search for this in Chrome, I think that we got our way. So then we're gonna need to print out an empty console log. Then move direction, comma, colon, and then actually print our matrix. Let's see if this works. Of course it won't, because we are not moving the matrices anyway, but you can see that up to here we're kind of good. Up to the part when we actually have to do something. Yeah, I guess these two lines will be good as well. Oh, as a matter of fact, the first move we got correct by doing nothing, because the analysis of the move is that it's gonna do nothing. So this is the first line where our solution will go wrong, because there is movement. So let's see how we can actually move our robot. Now the robot moves in those 4 directions, and if there is a box that can be pushed in front of it, it will push it in front of it. So we have the moving directions. So what the moves will be? The moves will be, if we are going up, we are reducing the y. If we are going down, we are increasing the y, reducing the x, increasing that. And the type of moves is, yeah, well, we can have some more types, but for now it's okay. We can take the move and we can calculate, we can need to find the robot. This is inefficient, very inefficient, but because there is only one robot and we already know where it is based on our last call, but we're gonna need to find the robot. Yeah. No, nothing like this. We can just have for loops. We have the y, we have the x. If warehouse of yx is equal to our robot, return X and Y, throw new error, robot not found. This works as it returns an X and a Y coordinate. The new position of the robot or updated position of the robot should be this much. So we're moving the robot in some direction by changing the X and the Y's, and that is, no, not the current one. We know that the current one is the robot. This is the current value of where our robot wants to go. And we have several different situations. If the current is a dot, then it's quite easy. We move the robot. So where the robot was becomes empty, where we want to move becomes the robot, we're golden. If it's a wall, that's also simple, because we just don't go into a wall. Do nothing. Otherwise, let's, for the sake of completeness, let's have this. If we have a robot at the place when we are, and we have a robot at the place when we want to go, then something went horribly wrong. So we're gonna do that as well. Yep. Otherwise, let's see what the current value is. The current value right now is of type crate, because that's the only type that was left. Remember that a cell can only be of 4 different values. So if it's not this, and if it's not this, and if it's not this, then it must be this. So we have that situation. And here we will have some calculation to do. For now, do nothing. Let's see if we start moving in the correct pattern, kinda. Basically, right now our robot will treat our crates like walls, because nothing will happen. So when we want to move left, nothing happens. We want to move up, we move up. We want to move up, nothing happens. Move that way, nothing happens, nothing happens, nothing happens. Moving down, moving left, moving down. Yep. Moving, nothing happens, nothing happens. Still moving down, moving down. Yeah, the moving so far looks okay. What we don't do is the crate movement. So the only thing that is left is we need to find out how to move crates. And it's relatively simple. So in this case, our robot has a crate, in this case actually. So our robot wants to move to the right, and it has a crate in front of it. So, and in front of that crate, there's empty space, which means that we can push that crate to this position. And we did that. And then we have this move. We have a crate in front of the robot, but in front of that crate is another crate. But in front of that crate, there's empty space. So we push to both crates in that direction. So in this case we have 4 crates, but in front of the 4th crate there is an empty crate, and we are able to do that. So if we have that situation, we need to find whether we can move. In front of us there's a crate. We need to find in that direction the first non-crate thing. Since we have walls on all sides, it will eventually run into a wall or into an empty space. I think we have walls on all different sides. Yes, even the huge input has that. So let's try to do that. So otherwise, and we still have the move that we want to do. So we know that the current which is on the updated direction, is actually a crate. So we will just loop while current. Let's leave the current as it is, but let's have another one. Let next cell. This is the next non-crate cell that we're going to encounter, and we're going to initially set it to the updated one. Or we can just do copy over the updated one over there, and which means we become the current cell, and this is the next cell. So while the next cell, something like this, while the next cell is a crate, and we know that the first time this will be definitely true, we move in the direction that we wanted to moving, and we take the next cell as well. And now we have two possible options. Is either empty or a wall. Thank you, Copilot. Yeah, that is correct. If it's a wall, let's do this later. If it's a wall, then do nothing. If it's a empty space, we do something. We'll check that code. I have no idea whether it's correct. And otherwise, we have an error somewhere. Something else went horribly wrong. No. So, if our next cell is a dot, let's see what happens. So we have this case. If we have this, that means that this cell doesn't actually change. What changes is the cell where the robot is, the cell where the first crate is, and the first empty cell. So those are the three that we need to change. And we actually have references to all three of them. This is the robot cell, this is the current cell, and this is the next cell. So what do we need to do? Well, the robot cell becomes empty. Yep, it got this one right. The updated cell becomes the robot, and the next cell